Hello everyone, I am Dr. M. Velumani, Assistant Professor, Department of Civil Engineering. Today we are going to discuss a very important topic in behavior of RC members in shear and torsion. These are the list of content: introduction to shear and torsion in RC, shear in RC members, types of shear failure, behavior of RC beams, shear reinforcement in RC members, IS 456-2000, shear design professions, introduction to torsion in RC members, behavior of RC beams in torsion, types of torsional failure, torsional reinforcement, IS 456-2000 torsion design provisions, combined shear and torsion. Now see about the introduction to shear and torsion in reinforced concrete. Reinforced concrete member not only resist the building but also shear and torsion. See the sliding along a cross section. Will torsion is the twisting of a member. Both are secondary but highly critical stresses, often governing the reinforcement design. If neglected, they causes sudden brittle failure. IS 456-2000 gives the provisions, and understanding these behaviors is key for safe and durable design. Shear in RC members definition. Shear in an internal force acting parallel to a section, protecting the diagonal tensile stresses. It is the maximum near supports in beams and cases inclined the cracking. Since concrete is weak in tension, reinforcement is required to control it. Shear must be checked in all RCC members because failure is sudden and brittle if not properly reinforced. Types of shear failure. There are four main types of shear failure: diagonal tension failure, shear compression failure, flexural shear failure, and punching shear in slab near columns. These cracks often occur at 30 to 45 degrees and are unsafe if not reinforced. The risk increases with the deeper beam and thin web. So providing the shear reinforcement ensure the ductility and prevent the collapse. Behavior of RC beams in shear. In beams, flexural crack form first, followed by the inclined shear crack form the supports. This reduces the strength and stiffness, and concrete alone cannot resist them. Stirrups carry the diagonal tension and bent up bars share the shear force. Proper detailing ensures the ductility and helps control the crack with effectively. Shear reinforcement in RC members. Vertical stirrups, inclined stirrups, bend up bars and shear link are used to resist shear. IS 456 specified the limit on spacing to ensure the effective action. Shear reinforcement transfer the diagonal stresses, prevent the brittle failure, and improve the ductility and serviceability for RC members. IS 456-2000 shear design professions. According to the IS 456, normal shear stress is calculated as V over B and D. It is the less than the code value. Only minimum steel is provided. If greater, designed reinforced is required. The code also limited maximum shear stress and stirrup spacing to 0.75 D or 300 mm. These professions ensure the safe and ductility behavior. Introduction to the torsion in RC members. Torsion is the twisting of a member, common in L-beam, H-beam, splinterless and staircase. Like a shear, it produces the diagonal tensile stress and spherical cracking. Torsion may be primary due to equilibrium or secondary due to compactability. Since torsional failure are sudden, closed stirrups and longitudinal bars are mandatory. as per IS 456. Behavior of RC members in torsion. When torque acts, diagonal spherical cracks form at about 45 degrees. Concrete has a very little torsional strength, so reinforcement is arrangement as a closed trusses. Longitudinal bars are resist the tension, while stirrups resist the diagonal stresses. Torsion also increase the bending and shear, making edge beam more critical. Proper detailing avoid the brittle failure. Types of torsion failure. Torsion failures include the pure torsion, torsional shear and flexural torsional failure. They are the sudden and severe in reinforcement insufficient, especially in the thin-walled members. Spanning of concrete and buckling of longitudinal bars may occur, reducing the stiffness. Hence, torsion must always be checked. Torsional reinforcement. Closed stirrups and longitudinal corner bars are the main torsional reinforcement. These are provided along the member length and arranged like a thin-walled tube. IS 456 require minimum torsional reinforcement, large cover and proper anchorage to prevent the brittle failure. IS 456-2000 torsional design provisions. The code uses the equivalent shear method. Equivalent shear stress is a V over B and D plus 1.6 D over B squared D, and equivalent bending moment is M plus M suffix D. Reinforcement is the design for these equivalent values. Closed stirrups and corner bars are always required for the torsional strength and ductility. Combined shear and torsion. In practical, shear and torsion often act together in beam and slab. Reinforcement must therefore be designed for the combined stresses. Longitudinal bars resist the combined moment, while stirrups resist the diagonal stresses. This generally requires for more reinforcement, especially in edge beams and cantilevers. Proper anchorage prevent the failure. Comparison of shear and torsion behavior. Both shear and torsion causes diagonal tensile stresses, but shear lead to inclined the crack, while torsion create the spherical cracks. Shear is resisted by the vertical stirrups, torsion by closed stirrups and corner steel. Shear is common in interior beam, while torsion is critical in edge beams. Shear failure are sudden, but torsional failures are even more severe. Both require tactile detailing as per IS 456 for safe design. Thank you for watching this lecture.